Hydrogen bonding. At the end of this lecture, I will teach you top exam-oriented questions. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Now, what is hydrogen bonding? Well, consider a single molecule of hydrogen fluoride. We know that hydrogen and fluorine atoms are chemically combined due to covalent bond. Hydrogen and fluorine atoms mutually share one pair of electrons and form a single molecule of hydrogen fluoride. And this molecule, fluorine, is highly electronegative than hydrogen. The electronegativity of fluorine is 4.0 and the electronegativity of hydrogen is 2.1. When we calculate the electronegativity difference of hydrogen fluoride, we get 1.9. This is very large difference in electronegativity. As a result of this, fluorine atom, being highly electronegative, pulls the shear pair of electrons more towards itself than hydrogen. The electronic cloud tilts towards fluorine atom and partially negative charge appears on fluorine and partially positive charge appears on hydrogen. So therefore we say that hydrogen fluoride is highly polarized molecule. Now consider another molecule of hydrogen fluoride. Like this molecule, it also has partially negative pole and positive pole. Here, there are two highly polarized molecules. Now listen carefully. The negative pole of this hydrogen fluoride molecule attracts the positive pole of this hydrogen fluoride and attractive force produces between them. Let me repeat it. The negative pole of this hydrogen fluoride molecule attracts the positive pole of this hydrogen fluoride molecule and attractive force produces between them. This attractive force between these two molecules is called hydrogen bonding. So hydrogen bonding is not a chemical bond. Rather, it is intermolecular forces between molecules. The word inter means between, thus hydrogen bond is attractive force between molecules. Also remember that covalent bond is intramolecular force. The word intra means within, so covalent bond is a force within atoms. Therefore, remember that hydrogen bonding is the attractive force or intermolecular forces between highly polarized molecules like hydrogen fluoride. Now let me ask you, does hydrogen bond exist in all hydrogen compounds like methane, ethane and propane? Well, the answer is absolute no. Hydrogen bond doesn't exist in these compounds because carbon is less electronegative. For instance, we should calculate the polarity of carbon and hydrogen bond. The electronegativity of carbon is 2.5 and the electronegativity of hydrogen atom is 2.1. When we calculate the electronegativity difference between these two atoms, we get 0.4. It is very small difference. The bond between carbon and hydrogen is non-polar. So all these molecules are non-polar and hydrogen bond doesn't exist in these compounds. Now what are the compounds in which hydrogen bond exists? Well, remember this mnemonic NOF. I mean nitrogen, oxygen and fluorine. When hydrogen forms a covalent bond with these three elements, hydrogen bond exists between their respective molecules. For example, hydrogen bond exists in ammonia, NH3, water, H2O and hydrogen fluoride, HF. Now hydrogen bond exists between molecules of ammonia, hydrogen bond exists between molecules of water and hydrogen bond exists between molecules of hydrogen fluoride. Thus note down this mnemonic NOF and remember that hydrogen bond only exists in ammonia, water and hydrogen fluoride. Now let me teach you some bullet questions regarding hydrogen bonding. What type of bond is a hydrogen bond? Remember that hydrogen bond is not a chemical bond. Hydrogen bond is intermolecular forces between molecules. Secondly, which is stronger, dipole-dipole forces or hydrogen bonding? Well, both hydrogen bond and dipole-dipole forces are intermolecular forces between molecules. But remember that hydrogen bond is the special type of dipole-dipole forces. Hydrogen bond is 10 times stronger than all dipole-dipole forces. Thirdly, is a hydrogen bond stronger than a covalent bond? The answer is no. Hydrogen bond is 20 times weaker than covalent bond. You can say that covalent bond is 20 times stronger than hydrogen bond. Fourthly, why does water have a high boiling point than hydrogen sulfide? If you see these both molecules H2O and H2S, they are very similar. But water has high boiling point than hydrogen sulfide. It is because water contains hydrogen bonding and hydrogen sulfide doesn't contain hydrogen bonding. This was all about hydrogen bonding.